So hello guys, welcome back to Gettobyte channel once again. I hope you all are doing well and are working good. In India, especially since the last decade, the automotive industry and sector has gone to a huge level. There are many new startups which have started coming up, and also many MNCs have launched their automotive projects, from silicon vendor MNCs to product based MNCs in India for the automotive development and innovation. Now, in this era of automotive, there are many complex applications that are being developed, from ADAS to vehicle communication to comfort in body and control and functional domains of the our automotive. The complexities and the emergence of embedded systems, especially in automotive sector, which is being considered as mechanical and hydraulic in traditional time, has increased a lot. So there are many silicon vendors who have launched their microprocessors, microcontrollers, and digital systems, specially targeting for automotive applications and industry. And in this, there is one NXP Semiconductors which has launched its NXP S32 platform of microcontrollers and microprocessors, which are specially targeted for automotive industry and fulfill its applications. One of the and microcontrollers of this S32 portfolio of NXP Semiconductor is the S32K144 microcontroller, which is being specially made to focus on the applications of automotive related to powertrain, body and control, and vehicle dynamics. So now in this video, and not only in this video, from this video, we are going to start with this controller only. We are going to do the firmware development of various sensors, automotive modules, sensors, and integration of those with the RTOS on this controller. So now, without wasting time, let's get started with this video. Now for fast prototyping and application development, NXP S32K144 has its evaluation board, which is very modular in size and specifically fit for the industrial projects, development of the automotive projects. S32K144 has rich set of peripherals. It supports CAN bus protocol, LIN bus protocol, FlexIO for emulation of the onboard protocols, UART, I2C, SP8 protocols. It also has rich set of highly efficient peripheral for of timers and ADC for making the projects related to the powertrain. And also, with apart from all these peripherals, S32K144 MCU also ensures the safety and security for automotive applications, and thus it also has a CSE higher security IP, which is embedded in the controller for having cryptography features on our automotive applications. Now moving on to the evaluation board, I will just show you the evaluation board and how does it look like, what all features and what things are there over the evaluation board, and then we will start with further software framework and development. So this is the NXP S32K144 evaluation board. As you can see, it is very modular in size, and this is the main chip, and all these are the existing header pins which are being exposed for using the all of its peripherals and connecting the external sensors. Also on the board you can see there are two LEDs. These are the two push buttons. Okay, and this is the reset button over here. There is one RGB line which is connected over here, and this is the ADC potentiometer, so as to use the ADC peripheral of this controller. Also on the onboard you can see there are these two these two pins. Okay, so these two are there for the CAN and the LIN protocol to be connected. CAN and LIN transceivers can be connected over here. There is onboard debugger on the this an evaluation board which is based on open SDA, and we can directly connect the USB cable over here, which is an on Android based. Okay, and we can use the onboard debugger from here. Also, the board can be powered externally from the 12-volt supply from here. And also on the onboard there is a support for JTAG debugging. So this is the JTAG connector on the onboard. Another thing which has to be marked on the evaluation board is also that there are two touchpads which are available on the onboard for testing its capabilities. So this is all about the which for just a short overview and the things which are available, the main things which are available on the board. Baki rest of the things I will tell you more on the upcoming videos, where I will be making firmwares for each of the peripherals. So using all the peripherals and connecting different sensors and modules, and also using these onboard features like serial debugging for OpenSDA, CAN and LAN transceivers will be connected over here. So now let's move on to the software framework part, where we will do the installation of necessary IDE, software development kit, and blink this RGB light of the evaluation board from one of the demo examples which is provided by NXP only. Now, so for connecting it with the with our laptop, I would be using the OpenSDA, the onboard debugger, okay, which is based on OpenSDA, and this is the USB connector. So it's an Android connector type base. So as you will connect your board at first time, so you will see that your these LEDs, the RGB LEDs, would start blinking, as this is the default program which is coded on it, and its onboard LEDs would be on. And this is the reset button, on which pressing the reset LED gets glowed and a program would be halted. So yes. So now this is the page for getting started with the S32K144 evaluation board. We need to set up some of the softwares in our desktop for getting started with this board. Softwares like its integrated development environment, its software development kit, and the debugging tool. In this video, we are not going to focus on the debugging tool. For that, I will cover in the next video or in another video, which will be typically dedicated for free master debugging tool of NXP Semiconductors. In this video, we are going to just download the integrated development environment. NXP Semiconductors had its designated S32 Design Studio, which is an IDE based on the Eclipse IDE for S32 Automotive platform. So this design studio supports all the S32, almost all the S32 Automotive microcontroller slash microprocessors. It also has built-in libraries, plugins for directly installing the software packages for the controllers which we want. So you can download the Design Studio IDE from the NXP website. Before downloading it, you just don't forget to log in into the NXP website. Okay, and after logging in, here should get as my NXP account. Okay, so you can just register yourself over, and then so I would be installing S32 Design Studio 3.5 Windows slash Linux. Okay, so now you just accept these terms and conditions, and then out of all these we will be installing the NXP S32 Design Studio 3.5 installer, which is of approximately 1.6 GB. So this is the Design Studio which I have already downloaded it, so I'm just going to open that only. Okay, so when it comes up, we will click on the yes. Okay, and now your installation will be started. Okay, so after its installation is done, you will see this page in which it will welcome you. You just need to click next, accept the, you just need to scroll down to the end, accept the terms and condition, then next. Where do you want to install NXP this, and I am naming it as new because I've already installed it, so I'm just doing this for the video demonstration. Next, next, and then install. Okay, so now it would be installing. Now when it will be installing, it would ask for you the activation key that it must have sent you on your registered email ID. So like I have this thing at the NXP, so I have installed it, and its NXP activation ID would be shown here, is showing here, this one. So you just need to copy it, and you need to paste it when it will pop out a window to Now, meanwhile, our design studio is getting installed. Let me just make you look over the software development kit for the S32K1 microcontrollers that would be needing, because our controller and is S32K144 evaluation board. So it stands for the S32K1 family. So I will be also showing like so this all these three links will be over at your video description. So in this software development kit, it would be having all the drivers of all the peripherals of the MCU. It would also be having some demo examples for demonstrating that how to use these low-level drivers of security, timers, SOS, communication protocol, analog, and all those things for demo examples, and would also be having the RTOS, free RTOS package with the S32 software development kit for the S32K1 microcontrollers. Now you can download it externally also from the here website, or once our installation of Design Studio is done, then we can directly install the S32 SDK software development kit RTD drivers from the built-in plugins of the Design Studio, which is S32 Design Studio. So we would be doing it by that way. If you want to explore on your own and need to know how does it looks like when we install it in the separate way, you can download it from here. Then what we are going to do, we are going to create a demo example, new project from one of the examples which is provided by the software development kit of S32K1 microcontrollers. So now as your installation gets complete, you can see the S32 Design Studio on your desktop. You can see its icon and you will double click it. So it will be loading to open your integrated development environment. First thing that we are going to do is install this RTD driver, the software development kit of K1 microcontrollers in our desktop in from via Design Studio. So you can see like I have already installed it, and I have also installed the RTM drivers. So you will see a folder by this way. Let me show you when this Design Studio will open. Okay, so now it opens and it will show you the workspace at which you want to start your program. So I have the by default is selected on its own, and I am just going to browse it, and I have created a folder by the name of document. So let me just create a new folder by the name of S32 K144 codes. Okay, and I'm going to select this as my workspace for this project. Okay, so now when you will launch the Design Studio, and when you are launching the Design Studio on a new workspace at the first time, so it will pop out by this. You can cancel out this progress information. Okay, it will pop out by the start page. Over here you can see your project explorer. Here it will show all the projects that you will have open, and it's just a normal interface. Is just like of a STM32 Cube ID, which is also based on Eclipse ID. So if you have worked on STM controllers, it would be pretty easy for you to get a hands-on on these controllers on the ID terms, because almost much of the things are very much similar. So now we will go, and first I will show you that how do you need to install the plugins, the software development kit for the microcontrollers directly from the IDE. So now when the progress is done, so it will show you all the softwares, all the extensions that can be installed on the Design Studio, all the available and all the installed that are installed in your local system. So in my local system, I have already installed the S32 SDK for the K1 microcontrollers. Okay, and it's RTM 4.0.1. So you can also download it directly from here. It will, if you will search in the type to search S32K1. So it will show you this thing. You just need to check on this, then install, click on the install button next, then it will be installed, and you need to restart it before it shows its content on your IDE. So I've already installed it. I'm not going to do it again, but I have told you the things. If you get any error or any issue, you can definitely refer them at the comment section or reach out to me via Gettobyte. Also, one thing that I want to mention is that what I have found when I am starting with this is the page of the NXP, the official page of the NXP. There are many things missing on this page which are not very well told, and like in the page, it is not mentioned that how do we need to install the this. software as its software development kit. Okay, and how do we need to use the demo examples. So that's what are the things that I am trying to cover, the missing things which are easy for beginners to start with these controllers. Okay, so now I am assuming that you have installed the SDK on your computer. Now we need to open a demo application project of the blink LED sketch. So at first I'm not going to start with the bare metal coding on the S32K1 microcontrollers. Maybe I am, but as if now I am not thinking to start bare metal. I'm thinking to start with its HAL only, which are provided, because there are quite a good number. It has good documentation also. If you will see, it's RTM and it's K144. So the documentation is also there. There is also PDF of specifically for S32 automotive controllers. Okay, so there are good number of documentations, and I am going to start with this because it would be easy for making the projects and building the automotive applications here easily. Okay, so you can check out all these things. You will be getting these two links you will be getting when you will install the S32 RTM driver on your this via Design Studio. Okay, so now this thing is okay. So now when you click on the file, new and new DS application project or library project or project from example. So at first we are going to open a new project from the examples that we have already that would be directly installed. It will be showing you once you have installed the RTM drivers. Okay, so when you it will be open. So if when you have installed the SDK of K1 successfully, so in the example section it show you this also. If this is not installed in your Design Studio, so it will not show you this section. It will only show you user examples. So make sure your SDK is installed. Select your microcontroller K144. What do we need to do? Driver examples or demo apps? We need to use the demo apps. Okay, and demo app of hello world S32K144. Finish, and then we will finish it. So now this project is going to be loaded on our project explorer and on the workspace that we have created for the this controller S32K144 codes. So on this workspace only I'm going to make all my codes and all my run demo examples. Now this is the code. Now we will go to the source and main.c. So main.c is the main code that is going to be executed in a microcontroller, and you will see I will make you understand what all these things are. These things, which function is doing what part and how is it doing on the Gettobyte website. So I would be making the proper evaluation boards, the blogs on the explaining all the packages, the SDK of the NXP control S32K1 SDK. So now you just open the hello world. I'm just going in this showing you how to run any demo example, and now click on the debug part. So what select a configuration to launch, and we are using PE macro. You have to select the S32 flash P macro. Okay, why PE macro? Because the debugger which we are using is OpenSDA, and OpenSDA is powered by the PE macro company. Okay, okay, and now it will be launching it. So let me just show you the hardware part, what is happening. Okay, so it is right now getting build and then configure, and this is our evaluation board. Build it with 0 error, 0 warnings, because this is the project which is already being supplied from the NXP. Now 50% is 50% shows if it builds successfully, and then remaining is launching the debug configuration. So as its debug configuration is launched, you can see that it's this on go board LED is stopped blinking, and this is open, and remember my decision, and then switch. Okay, and yeah, it would take some, and you can see on the board part also. Okay, so it has stopped and your debugger is launched, and just like in the Design Studio, there is same what this is showing you, the STM cube ID is there. So now this is the run part. So now you can make the code run one by one. So now you can see as I have run it, this LED starts glowing because pin configuration is done, it's being set, initialization is done, and now output value. Okay, so it has been now green. Previously it was yellow, and now yeah, pin. Okay, so now toggling it, you can see color is changing, and now if I make it blink, so my LED is glowing continuously. So you can see we have controlled. No, like we have not written a code. I am just showing you the demonstration on how to play with these controllers with the NXP provided frameworks of its software development kit and its IDE. So I hope you get to know new thing about the things in this video. This video is quite long, I think so, and the you regularly check the website of the Gettobyte. Also, I am making many new blogs on the Gettobyte website related to the RTOS these days also. So my main idea is to integrate RTOS based projects on this controller. So that's it for this video. I hope you get to know some valuable things in this video, and do subscribe to the Get to Byte YouTube channel for any other things. Okay, and yeah, so see you in the next video. Bye bye, namaste, and so that's it for now. Like the video, subscribe the channel, and press the bell icon to get notified for new videos, and share it with your friends.